All right, guys. Today I want to talk about if we got questions about the homework, we can ask those at the end. Looking at what you guys have already done on the homework, it doesn't look like there's a lot of questions or issues with that. I do want to remind you that that's kind of the purpose of leaving them open until the evening, so that you can look at it yesterday. Run through, if there's 25 questions, run through them all, and maybe the 4 or 5 that you don't understand, you can present those as questions the next day. So let's make sure that we are doing that now. I know that some of the stuff that we're working on right now might not be something that you think is extremely difficult. Okay, and I would agree with that. I would. And I told the last class I'm gonna argue to you that when we start to write these statements, it's defined on how you create them. It tells you identify the hypothesis, the conclusion, and then you flip them, or you negate them, or you do both. Okay, and that's kind of a monkey see, monkey do type thing. Show me how to do it once, I can do it twice. Okay, but what I want us to be able to do, and the reason that we do these 2 sections, is because you can all read, you can all follow directions. Okay, but do you know what you've read? Do you know why you're following certain directions? That's what this is about. Okay, you've all been in a situation, and they put yourself in an English class. You guys have read Shakespeare, right? Okay, and you read Shakespeare, and you can read every single word. There's no words in the entire text that you don't know what they are by themselves. Okay, but the structure of it and the way that they're phrased and things like that, you might read it and say, okay, I read it, I don't have a clue to what it said. Well, I can't comprehend it, correct? Okay? In mathematics, you're going to be able to read everything. There aren't going to be any words that you cannot say or read. You passed 3rd grade. You know how to read. Okay? The issue is, when I read that, do I know what it's saying? Am I comprehending the information to a point to where I know what it means, and now I can take that information and apply it to something else? Okay? Does that make sense? If we can all pick up a law textbook and read all the words in a law textbook, but can we interpret what those laws mean? Can we apply those laws? And that's what we're doing here in this course. Okay. So the stuff that we talk about today, you're going to hear me say it a couple different times today. You're going to be able to follow the structure of these sentences. You're going to be able to rewrite them the way that we're supposed to, based off the directions that we're given. But when you see these things later on in another chapter, and it uses the phrase if and then, do you know how to interpret that if-then statement? If it says the words if and only if, like we talk about today here in a little bit, are you going to know that that means something completely different than the phrase if-then? Okay? So that's kind of what we're trying to get at here. All right? I'm trying to teach you how to read a math textbook. Okay? And also, your sciences kind of play off of this as well. Okay? Your law textbooks would be this way. But we're going to get into a biconditional, and that's using a biconditional or learning about biconditional. We obviously have to know what a conditional is. Okay? What's the prefix bi mean, first of all? 2. Okay, it means 2. And conditional, we said a conditional statement yesterday and the day before was simply a if-then statement, right? So when we see biconditional, it's 2 if-then statements. 2 if-then statements, okay? But more formally, it's a single true statement that combines a true conditional and its true converse. So it's more than just saying it's 2 conditionals, okay? It's 2 conditionals that are related to one another as a true conditional statement and its converse, okay? When we use a conditional statement, like an if-then statement down here at the bottom, I just want to jump down to this blue phrase. Okay? If I were to take that blue phrase and read, it says, if the sum of the measures of 2 angles is 180, 2 angles added up to 180, then the 2 angles are supplementary. Would you agree that that's a true if-then statement? You have 2 angles add up to 180. That's happening in front of you. You can then make the conclusion. You can call those 2 angles supplementary. That's a true statement. Okay? That's the original conditional. take a moment on your own and write down what you think the converse of that statement would look like. You come up with something that says if two angles are supplementary, then the sum of their measures is 180. That's just taking the if part and the then part and flip-flopping them, right? Okay? That's what we call the converse. Would you agree if that's true? If you have two supplementary angles in front of you, you can tell me how many degrees they're going to add up to? You know they're going to be 180, right? So this is a true statement. Okay? So we have a conditional statement, the one in blue that we said was true. We flip-flop it, and we get a converse, and it is true as well. Okay? So in total, we have two true statements, two things that are facts. So these two things are facts, so we like to add these to our bank of knowledge for this course. Okay? But if I'm going to write them down, or if I'm trying to memorize something, would you rather write down or memorize 40 words, or would you rather write down and memorize 20 words? Most people would say 20, right? Okay, you'd like to do less. You'd like to, if I can say something in a less amount of words, be more concise with it, I'm going to do those things. Okay? So what we like to do here is take those two phrases that are true and rewrite them as what we call a biconditional. So I'm going to show you how we do that. Okay? To come up with a biconditional, which is a phrase that is going to encapsulate both of these true ideas. Okay? The first thing you're going to do is just choose one of the two statements. It does not matter. Choose either the conditional or the converse. Okay? And let that be your original structure. So I'm just going to grab the one that's blue there, and I'm going to basically rewrite the whole thing, but instead if and only if. Okay? That takes the place of the word then. And then I write the rest of the blue statement. So if and only if, and then it picks up the two angles. Are supplementary. You guys know how, like, when you're in English class, you guys talk about, like, declarative sentences, you talk about imperative sentences and those types of things, okay? And I look at you and I say, write this down. That's an imperative statement. That means you write this down, correct? Okay, it's that you understood type thing. So there's grammatical practices that we do inside an English class that imply certain things. Okay, put an exclamation point on the end of something. Tells us how we emphasize that when we read it, right? Okay? In mathematics, the if and only if phrase is a grammatical thing that we've developed that says you can now interpret this statement two ways. Okay? You can read it, the sum of the measures of two angles is 180 if and only if the two measures are supplementary, or you can actually read it from right to left. Okay, so start at the back of the sentence. Say, two angles are supplementary if and only if the sum of their measures is 180. Does that kind of make sense? So inside that statement there that I wrote in white, about 20 words is the 40 words that are encapsulated there, okay, and still have the same truths that we initially started with. Does that make sense, everybody? So why are we talking about that? Because later on throughout the year, when we get a statement that is an if-then statement, they are writing it that way intentionally, okay? So yesterday, I think we've seen this example. If you live in Ohio, then you live in the USA, right? Okay? I'm writing that, let's say that is a mathematical principle, a guideline that we have to abide by in mathematics. I'm going to write it that way because that's the only way that I want you to interpret it. And that's the only way that I want you to use it and apply it. Okay? Because if you reverse it, look at the converse down there. If you reverse it, that rule or that law is now false, is it not? Does that make sense, everybody? Okay? If you live in the U.S., then you live in Ohio. Well, there's counterexamples to that. Now, that's kind of generic, so let's do this. Let's say if a shape is an isosceles triangle, then it is a triangle. Now, I think that's a stupid phrase, so don't kind of balk at that yet. It's kind of trivial. It's obvious, right? If it's an isosceles triangle, then obviously it's a triangle. Well, if I write the kind, and that's the way I'm going to present it to you. Okay, I'm going to say that is a mathematical fact. And that's the way I want you to interpret it and apply it. Because if I take the converse, which is what we want to inherently do in mathematics, is people want to reverse things for some reason. If I reverse it and I say if a shape is a triangle, then it is an isosceles triangle, isn't that false? Couldn't it be scalene? Couldn't it be equilateral? Okay? There are different options for it. Does that make sense, everybody? And we'll talk about if it is equilateral, it is also isosceles. But there are different things that could exist there. So when I give you a mathematical rule for the rest of this course, if it's written with the words if and then, that's the only way that the author of the book wants you to comprehend that statement. That's the only way they want you to interpret and use that statement. Does that make sense? Okay. If they were to use the words if and only if, this will happen occasionally. It's not as much as the phrases if and then, but if they were to use the words if and only if, they're telling you with that grammar that you can read it backwards and forwards. You can apply it both ways. Okay. When we talk about biconditionals, just like the conditional statements, okay, we have some symbolism that we can use that can kind of rewrite the definition or kind of bottle up this concept in a little bit more concise manner, okay, using this symbolism. Yesterday, basically, we talked about the idea that if I had a conditional statement, so a conditional was P implies Q, or if P, then Q, right? And the way that we interpret that says, if P is happening in front of me, if that's my specific scenario, then I can apply Q to that. I can see what the conclusion is. I can make a conclusion off of it. What a biconditional does is this. It says, notation-wise, P, and then we have an arrow that is a two-way arrow, and it says Q. Okay? And because that's a two-way arrow, kind of mean it's a two-way street. You can either start at P and then get to the conclusion of Q, or you can start at Q and then get to the conclusion of P. This here says the same thing. I can start with Q, double arrow, and then P. Okay? But what both those imply to me is that not only is this thing P implies Q true, but it implies that Q then P is also true. Both of those things are true. And that's what I need you to understand when you see the words if and only if written in a statement. There are actually two statements being provided. Okay? Does that make sense? So if I say, a triangle is equilateral if and only if it is regular. Okay, now I know you might not know what those words mean yet. Okay, so if a triangle, a triangle is equilateral if and only if it is regular. Okay, this phrase, that's not a miss or typo or anything like that. IFF stands for the phrase if and only if, so we don't have to write that out over and over and over again. But if I write that, a triangle is equilateral if and only if it is regular, what I am telling you then is that if you have a triangle that is equilateral, you can now call it regular. Okay? So this is giving me two statements. This is saying if a triangle is equilateral, then it is regular. And I'm telling you that is absolutely 100% true. Okay? But it is also, because of the if and only if,